I feel very fortunate to be here today, and I'm excited to talk about wind. We are going to talk about frequently misunderstood wind provisions, and in some cases that's going to be provisions that are explicitly in the code but still confusing. In some cases we'll be talking about provisions that maybe the code is silent on, but as practicing engineers we come up against day in and day out. So we'll go ahead and get started here. The topics we're going to talk about today, we're going to focus quite a bit of time on enclosure classification, which feels very simple, and it certainly is addressed in a quite simple fashion in the code, but we find a tremendous amount of questions revolving around this particular topic. I'm also going to spend a little bit of time, anyone who's heard parts of this lecture or pieces of it, there are some new components that we're introducing today, and enclosure classification is one of them. We're going to talk about a new addition that will be showing up in the ASCE 716 code for enclosure classification. We're going to spend a little bit of time talking about analysis methods. Again, this is probably the most confusing part of the WIN code, is the number of chapters, the number of methods available to you, and we'll try and simplify that down a bit. We'll talk about torsional effects. Something we do need to be concerned about with wind load, but is addressed in a fairly confusing fashion, so we'll break that down. The next is canopies, and that's something that we as practicing engineers deal with day in and day out, yet historically the code has been very silent on an appropriate wind force to put on a canopy. We'll talk about corner zones very briefly, in addition to effective wind area, and that's a term that's unique to the wind code, similar to tributary area, but with some nuances, so we'll focus there. We'll talk about rooftop solar and PV, again, similar to canopies, something that very often is controlled by wind design, even in high seismic territories, yet the code historically has been a little bit lagging behind the technology as it relates to what wind loads to put on these PV. And we're going to finish up, historically the last section's been focused on ASCE 710, and whenever I do this webinar, seminar, or something similar, I get very split feedback on this section of our presentation. I have about half of the audience that says that was great, we're just about to adopt IBC, that incorporates ASCE 710, and it was so great to have that heads up of all of these large changes because they are very impactful. The other half of the respondents say, hey, my jurisdiction's been in ASCE 710 for years. This is old news. We've got it. That was a waste of my time. So what I'm going to do is also give you some updates on ASCE 716. So we'll talk a little bit about 705 to 710, and then where appropriate, 710 to 716 to hopefully appease all parties. So with that being said, we'll go ahead and get started. As I mentioned, our first topic is enclosure classification. And in order to address the problem, I find it easiest to work through a sample project. So this is an agricultural building. It's in California. So in these types of environments, even our high seismic doesn't typically control a building like this. And you can see it's primarily open on three sides, with the back face of the building enclosed, or closed, I should say, and a fairly fully covered roof. And I'll ask the question, in ASCE 710, we have three options: enclosed, partially enclosed, and open. And what we'll do is we'll work through the problem to determine which of these three are the appropriate classifications. In order to do that, the first thing we need to understand is what is an opening. Obviously, the building we just looked at, it's pretty obvious. It's wide open. There's no window. There's no door. It is an opening. But we often come across buildings that have much more gray area. For example, louvers, windows, whether they're operable or not, doors, overhead doors, that sort of thing. So we'll talk about what constitutes an opening, but assuming we understand whether a door or window is an opening, it's quite simple. An open building here is a building where each wall is at least 80% open. So the important thing here, and I've italicized it, is each wall. So all of our walls of the building need to be at least 80% open. To classify as a partially enclosed building, we have a two-step definition, and it's very complicated, it's very wordy, so I'm going to ask you to stay with me, and if it's still confusing, we'll address it with specific numbers in our problem. But a partially enclosed building is a building that complies with both of these two conditions, condition 1 and condition 2. Condition 1 says that the total area of openings in a given wall. So we're going to pick a wall. We're going to sum up the openings. Then we're going to, on the other side of the equation, sum up the openings in what we call the balance of the building envelope. So we're concerned about, if it's a square rectangular building, the other 3 walls and the roof. And the roof is a key part that a lot of people forget. We're going to compare those 2 numbers. So again, the openings on our one wall versus the openings on the other 3 walls plus the roof.